So, what is safe and wholesome water? What is the criteria? Free from pathogenic substances, free from harmful chemical substance, pleasant to taste, free from color and odor, usable for domestic purposes. Okay, this you all know. If any of the above criteria is not fulfilled, it is polluted water. Alright. Then how much water requirement do we require per day? 2 liters per person per day, irrespective of the weather, whether it's sunny or rainy or winter. Domestic use 150 to 200 liters per day in urban area, 40 liters per person per day in a rural area. Okay. Now these sources of water, we know all this. Rain, surface water. Surface water, again you have reservoirs, rivers and streams, tanks, ponds and lakes. Groundwater, shallow well, deep well, springs. So this is how the polluted water looks like. Water is all over the place. Okay, we don't know what the source of water is. So what are the impurities in water? You have natural impurities as well as man-made impurities. Natural are from the atmosphere, from the soil, from the catchment area. Catchment area means if say for example the Ganga is emptying into Hooghly, but the catchment area starts right from Gangotri or even further up to Gomu. Then dissolved gases picked up during rainfall like nitrogen, carbon dioxide, hydrogen sulfide, dissolved minerals, particularly calcium, magnesium salts and sodium, and suspended impurities like clay, silt, sand and mud. So these are the usual impurities that are present. We also have impurities in the groundwater. Okay. So man-made impurities include sewage, industrial. What is sewage? What is sewage? Bola? What is sewage? What is sewage? What is sewage? You have your exams after 2 months. What is sewage? What is sewage? Bola. Bola, bola. What is sewage? You have exams after 2 months. What is sewage? You should tell me. What is sewage? Don't Google for that. What is sewage? What is sewage? Nobody can say what is sewage. Huh? Okay, human excreta, human waste which comes from the bathroom, that is sewage. So what is sullage? S-U-L-L-A-G. Other means what? Like example? Kitchen waste. Very good. So that is it. So sewage, industrial waste. So sewage is basically from human stool and etc. Industrial waste, agricultural pollutants, physical pollutants. And then you have water related disease, biological waterborne disease, and chemical disease like pollution from detergents, cyanides, heavy metals, minerals, organic acids, etc. So what are the effects of water pollution? You all know this: diarrhea, vomiting, abdominal pain. You can have typhoid, dengue, hepatitis, kidney damage, nerve disorders, skin lesions. All these are problems caused by water pollution. Okay. So what these are waterborne diseases which are there? You have right at the top you have hepatitis A and E. You have poliomyelitis, rotavirus diarrhea. You have among the bacterial you have typhoid, paratyphoid, bacillary dysentery, cholera, E. coli. Protozoal you have MBBS, giardiasis. Among the helminths you have roundworm, threadworm, hydrated disease, and leptospiral disease. It's also called Wills disease. And you have also disease caused by aquatic hosts like schistosomiasis, which is caused by snail, and cyclops causes fish tapeworm disease and guinea worm disease. Okay. Again, waterborne disease, you can have another classification like bacterial diseases, viral diseases, protozoal. So bacterial disease you have typhoid, cholera, paratyphoid, bacillary dysentery. Viral infections you have hepatitis A, poliomyelitis. Protozoal infection you have amoebic dysentery. Then again, chemicals in water, pesticides, organophosphorus compounds, they can cause cancers. Lead can affect the central nervous system. Fluoride, excess of fluoride affects the teeth and skeletal system. And arsenic. Now in West Bengal, arsenic is a big problem. You still have a lot of wells which have the high content of arsenic, particularly in South 24 Parganas and all. Then polluted stagnant water acts as a breeding place for Culex mosquito and other flies. And polluted water generally causes skin irritation, eye irritation, respiratory tract infections. Okay. So now we come to the main crux of the thing. This was just by way of introduction. Purification of water on a large scale, a small scale and a large scale. So in the small scale, what do we do? Household purification of water. And second thing is disinfection of wells. So household purification of water and disinfection of wells. Something wrong with this mic here, no? But we'll move on. So commonest method for purification of water is boiling. And second one is chemical disinfection with bleaching powder. What is bleaching powder? What is formula of bleaching powder? CaOCl2. Then you have chlorine solutions and tablets and iodine and potassium permanganate for chemical disinfection. Then you have filtration. Okay. So this is a chlorine tablet which you are seeing on the top left. You have bleaching powder on the bottom, and these are again the tablets loose. Okay. This is used for disinfection in a small scale. So this is again wherever there is a flood, usually they say chlorinate the water. They say 1 chlorine tablet for 20 liters of water, 12.5 grams for 500 liters of water. This is just a rough estimate. 25 gram tablet for 1000 liters of water. They say that do not boil water for 20 minutes before consumption, even though the water has been chlorinated. This is for the flood situation. Okay. Now, if you look at purification of water on large scale, we have 3 components. One is storage, one is filtration, one is disinfection. So, surface water, which is the river water, that is the one which is more turbid, which requires treatment. So, you have 3 parts: storage, you are storing the water somewhere, then filtration, and then disinfection. So, storage, the river water is stored usually for up to 5 to 7 days. So, some improvement automatically occurs. Physical quality improves, 90% of the suspended particles settle in 24 hours. Chemical improvement also is there. There is oxidation of organic matter, and biological improvement is also. So, if you keep water, you will allow it to settle for some time. Definitely these 3 things will improve, but it's more than 7 days. Okay. In 1 day it will become bad, but 7 days, definitely these 3 things occur. That is physical improvement, chemical improvement, suspended impurities, aerobic oxidation of organic matter, and biological improvement. So, this is how the water is stored. Okay, a big place like this, the water is stored. So, for 5 to 7 days, so that all the impurities settle down and the oxidation is better, all this. Okay. Then the second one is the filtration part. Filtration part is the most important part, where 98 to 99% of bacteria are removed. Here you have 2 filters, a slow sand filter and a rapid sand filter. This question is asked, how many filters are there? Name them. Okay. So, slow sand filter, you have raw water, then you have below that you have sand, you have an under drainage system and a system of filter control valves. So, this is how it looks like. Slow sand filter. So, this is this inlet chamber, right? So, you have gravel over here, you have sand over here, and this water continuously flows. Okay, and this is the outlet of the water. So, this is how a slow sand filter looks like. Okay, the water enters here, and this is you have a gravel, sand, and you have under drains. That's how it moves. Okay, slow sand filter. And this is the slow sand filter, the same thing. You have an inlet, you have an outlet, you have a drain, and a pipe is used for cleaning the filter. So, depth is between 1 to 1.5 meters and always kept constant. You always have constant head. Head means continuous water is there and provides a slight waiting period. That is, always there is some water over here, so the water does not go out straight away. Okay. So, that is what the slow sand filtration is all about. Then there are some specifications about the sand bed. 1 meter is the thickness, effective diameter is between 2 to 3. This is a sagittal view. So, you have the pipes here, coarse gravel, fine gravel, coarse sand, and filter sand. So this is just a figure which is there in the book. You don't need to read much, but this is how it looks like. Okay. Then you have what is called the vital layer. The vital layer, again a question which comes in the university. What is vital layer? Or this unpronounceable name, Schutzbuddek. It means the zooglial layer or the biological layer. So this is a layer consisting of thread-like algae, plankton, diatom and bacteria. So this is the heart of the slow sand filter. When water keeps flowing, this gradually over a period of time, this thing appears. It removes the organic matter and holds back bacteria and oxidizes nitrogen into nitrates. So this is the biological activity occurring here. Okay. So, and periodically you have to scrape it. So in other words, the biological layer is also zooglial layer, biological layer, vital layer, all are the same. So if you ask a question, what is the biological layer? Don't get confused. It is just mentioned. It is a layer on top of the heart of slow sand filter. What it does, it holds back bacteria, removes organic matter, oxidizes nitrogen into nitrates, cleaned by scraping. Okay. So very common question is, what is zooglial layer? What is biological layer? And what is food structure? These are the common questions which are asked in the oral as well as short notes. Then you have under drainage system, which has perforated pipes. We saw in the earlier picture. And advantage is that it is easy to construct. The slow sand filter is easy to construct and its cost is less, and physiological, biochemical and bacteriological quality is very high. It reduces bacterial count by 99.99%. Then you have rapid sand filters, what you would normally see in the filter which we normally use. This comes under that only, gravity filter, pressure type. So before that, we have, the first thing is the raw water is treated with alum. Alum is aluminum sulfate. So 5 to 40 grams per liter is added. That is called coagulation. Then it's mixed in a rapid mixing chamber, and then there is stirring done. In slow sand filter, there is no stirring. So that is what is called flocculation, slow and gentle stirring for 30 minutes. Then you have white precipitate gets formed. Then sedimentation. The water is retained for 2 hours. Then the water is subject to filtration. So there are 1, 2, 3, 5 steps in slow sand, rapid sand filtration. Okay, 5 steps. So what are the 5 steps? Can anybody mention what are the 5 steps? Jayashree, what are the 5 steps? What are the 5 steps, Jayashree? Mention the 5 steps. What are the 5 steps in rapid sand filtration? Batao. Bolo. Okay, what's your name? I forget somebody else's name. Some other person I'll catch. What are the 5 steps? This is straight in front of you. Coagulation, rapid mixing, flocculation, sedimentation and filtration. Okay. So this is how it looks like. First you add alum, then it goes to the mixing chamber, then it goes to the flocculation chamber, sedimentation tank, then goes to the filters, then it's the clear water storage, and that is finally out for consumption. Okay. So this is more complicated than the slow sand filter, obviously more costly also. And here this is some other details regarding the filter beds. Each filter bed has an area of 80 to 90 meters squared, size of the particles, water column specification, etc. etc. Filter beds occupy less space, filtration is rapid, washing is easy, but more flexibility in operation. So this is again a question which is asked. Rapid sand filter occupies less space, slow sand filter uses a large area, and different things. The preliminary treatment here is slow sand filter is plain sedimentation. Here it is chemical coagulation, and roughly removal of bacteria is almost same in both. The only thing is the space factor and the rate of filtration. These are the things which are the difference in slow sand and rapid sand filtration. Okay. Now, after the filtration, we have to disinfect it. So, how do you disinfect? What is disinfectant? A disinfectant should be able to destroy the pathogenic organism within the available contact time it should not render the water toxic. Suppose you add a lot of bleaching powder to water, what will happen? You cannot drink the water, you cannot use it for anything. And should be available at reasonable cost and possess the property of leaving residual concentration to deal with contamination. That means residual concentration means suppose further contamination is there, that thing should be there, that particular decontaminant should be there to deal with it. Okay. And be amenable to detection by simple analytical technique. So disinfection, the commonest thing is chlorination, but has no effects on spores and virus like polio except in high doses. But it oxidizes iron, manganese, hydrogen sulfide, it destroys taste and odor, it controls algae and slime, it helps in coagulation. Okay. So acts best when the pH is around 7. So what is this chemical formula? Hydrogen plus chlorine gives you HCl and HOCl. What is HOCl? What does your chemistry say? What is HCl? What is HCl in chemistry? HCl is hydrochloride. What is HOCl? Hypochlorous acid. So HOCl is again broken up into hydrogen and HOCl. Okay. So these are principles of chlorination. Water should be clear and free from turbidity. Chlorine demand should be estimated. Contact period should be at least 1 hour. And recommended concentration for free chlorine is 0.5 milligram per liter for 1 hour. Okay. Now this is sum of the chlorine demand plus free residual chlorine constitutes the correct dose of chlorine to be applied. So I'll just show you how it occurs. So these are two terms which are there. First is chlorine demand. You have to find the chlorine demand, how much liters are there, how much chlorine is to be required. That we will show you shortly. Contact period of at least 1 hour is required. And minimum concentration of free chlorine is 0.5 milligram per liter for 1 hour. And the free chlorine plus the residual chlorine, I mean chlorine demand plus the residual chlorine constitutes the correct dose of chlorine to be applied. It's a bit complicated, I know, it's not easy to remember all these things. But this is the thing which you should know, breakpoint chlorination, the point at which residual chlorine appears and when all combined chlorines have been completely destroyed is the breakpoint. So after this, all the combined chlorines have been destroyed, that is called the breakpoint dosage. So then we have another term which is called superchlorination. This is usually done in cases of floods or some emergencies. Now we go on to orthotoluidine test, and here this enables to know both free and combined chlorine water. So here you have orthotoluidine is dissolved in 10% of HCl, and that's a modification that shows the free and combined residual separately and overcomes the error caused by the interfering substance. Okay. So, so we will not go into quality standards now, but okay, just can you tell me what is wrong with this? What is there in this photograph? Can you see this photograph? What is there in this photograph? What all can you notice in this photograph? Tell me. What can you notice in this photograph? What can you notice in this photograph? This is taken not in West Bengal, it's taken in Jharkhand, a place called Pakur, 2 hours from here. What can you see in this photograph? What can you see? Huh? Tell me, a lot of things you can see. Huh? What can you see? Tell me, so you can see, what can you tell me openly? You can see children, right? You can see 2 ladies or 3 ladies. 1 lady is hidden there. 4 ladies, sorry. 2 ladies sitting, 2 standing. What else can you see? What else can you see? Bola. What else can you see? They are washing. What else? Washing the, huh? What is it? Washing, drinking, what else? Washing, drinks, maybe somebody's washing, wiping his legs or whatever it is. So in one pond, the entire place is getting polluted. Okay. This is a real photograph in Pakur in the year 2008, not very far away. Okay. So this is an example of the pollution which occurs. So if you see this picture, for those who can't see, this child is having water. She is washing her bartan this girl or whoever it is washing, cleaning something. This chap, he's just gone to the bathroom probably. So everything is going on in this same photograph. So that's how important, just to show you the importance of how this water purity should be. Okay, they don't have a choice. There's one pond in the village. So this is what we saw. Okay, this is what just come here because you can see this thing over here. This, germicidal action kills pathogenic bacteria and controls algae. You can come in front. What's the problem? Better. Oh, sir. So this is what I just talked about, chlorination. She's done this. You destruction of chlorine by reducing compounds. So formation of the chloro-organic compounds, the combined residual chlorine is this much. Then you have, it is destroyed. And this is the breakpoint chlorination. Okay. Formation of combined residual and free residual. Then next is this important thing called the Horrocks apparatus. Now what is Horrocks apparatus? So this is what the Horrocks apparatus looks like. This is a question which is asked. Describe the principle of finding bleaching powder demand of water by Horrocks test. So this is what it looks like. You have one glass with a black, one beaker with a black thing. Then you have 6 other small glasses of same size, which different measurements. 6 white cups you can see. Here it's a transparent cup. So one black, 6 cups. Then you have this potassium iodide. This is starch, soluble starch. This is bleaching powder. Okay, this is bleaching powder. Please take a look here, second last bench, third last bench. The boys behind Apreksha. Please look, what is this? This is not a surf, this is bleaching powder. Okay. So you have bleaching powder in this. You have starch here. You have universal indicator solution here. Then you have potassium iodide solution here. Okay. Apart from that, you have spoons. The spoon, 2 ml spoon. Okay, you have 2 spoons. Then you have a glass pipette. In fact, number of glass pipettes. Okay, for stirring. So what happens next? I showed you all this stuff. What happens next? So one black cup with circular mark. This is a mark over here. 6 white cups of 200 ml each. These are 6 cups. 1 pipette and 2 metal spoons and instruction folder. Then you have starch, iodide solution powder, and which is prepared by adding 1.5 grams starch in. This is at the moment we have starch powder. This is starch powder, but you can add it and make the starch iodine solution. Potassium iodide is also added. Okay. So this is how it looks like. Then this is what is done next. Take the black cup. I've taken the black cup. Put 2 grams bleaching powder in this. This spoon contains 2 grams. 1 spoonful is 2 grams. Add little water till a thin paste is made. Then add more water up to the circular mark. Up to this mark, you add water. And you stir it with the rod and this allow it to settle. That is called stock solution. So you add 2 grams, then fill it up with water till here, and that is called stock solution. Then 6 white cups are arranged in order. These are 6 white cups. So now you fill up the water to be tested. You're pouring different waters in different cups. Okay. So with 1 drop is added to first cup. There was your order. Suppose the first, second, third, fourth, fifth, sixth. 1 drop is added to the first cup, 2 drops to second cup, 3 drops to third cup, etc. And all the water is stirred using a separate glass rod. Okay. So after adding the water, you're stirring it with a separate glass rod, and the cups are left undisturbed for half an hour for the action of bleaching powder and liberation of the chlorine. Then you add 3 drops of this starch indicator to all white cups by stirrer and stirred again. Okay, you are adding 3 drops of this. This is a thick soluble, but that is the solution. And in development of blue color in this indicates that there is presence of free residual chlorine. That means it's okay. Presence of blue color indicates presence of free residual chlorine. Is it clear? Have you understood so far? Or do you want me to repeat? Just follow, huh? You want to repeat? Okay. I'm repeating once again. Go to the slides once and first you take the black cup. This is a black cup. You take 2 grams using the spoon. The small spoon you're taking 2 grams of bleaching powder you're taking, adding it. Then you fill up water up to this circular mark, allow it to stand, and then that's called stock solution. Then you arrange the 6 cups in, the white cups in some order. Okay. Then you add again stock solution, 1 drop of this solution. With a pipette, you take 1 drop, you pour it here, 2 drops you pour in the second glass, 3 drops in the third glass, 4 drops in the fourth glass, 5 drops in the fifth glass, 6 drops in the sixth glass. Is it okay? Then for half an hour you wait. Okay, and you stir it. You stir all the glasses. You wait for half an hour. Then the cups, after half an hour you see what it is. Then you add 3 drops of this freshly prepared starch solution. This is starch powder, but the solution is added to this different cups. Okay. So a blue color which indicates free residual chlorine. So note the first cup which develops blue color. So amount of bleaching powder to disinfect 455 liters is the first cup which develops a blue color. Now, so this is the principle. This indicator contains potassium and iodine starch. Free chlorine reacts with potassium iodide, and iodide reacts with starch and gives a blue color. Is this part clear? Is this part clear? Horrocks apparatus, is it clear? Call your friend. Is it clear? किसी बुझ ले? की बुझ ले? की बुझ ले? Okay, now this is an example of a question. There's a tank which contains 45,500 liters of water. Horrocks apparatus shows blue color in 5th cup. Calculate the required amount of bleaching powder for disinfection. Huh? Somebody said 1,000. Okay, let's see how it works out. So 5th cup is the first cup to develop blue color. So amount of bleaching powder to require 455 liters is the 5 into 2. That is the number of cup into 2. Suppose the first cup 1 into 2. Here it's 5th cup. So 5 into 2. So the amount to disinfect the tank in Medical College Hospital is 10 into 45,500 divided by 455, which is 1,000 grams. He's given the right answer, 1 kg. Good hand, give him a big hand. So 1 kg of bleaching powder is required to disinfect the tank in the medical college. Is this clear? So the number of whichever cup is the first cup, that multiplied by 2, that many grams is required to disinfect 455 liters of water. Is it clear? Is it clear? Suppose the third cup is becomes blue first. So what do you mean by that? So how many grams are required for disinfecting 455 grams? 455 liters? Suppose the third cup is a blue color. Okay, 3 into 6 grams is required for 455 liters. Okay. So if it is the fourth cup, 4 into 2, 8 grams. Is it clear? So the serial number of the cup into 2. That is the amount required to disinfect 455 liters of water. Okay, so here's this formula. Is this clear? This question is clear. Is this clear for everybody? Okay, we'll move on. Now this is a question which you people have. 1,000 liters of water is there. bleaching powder was found to be 2 grams in Horrocks test. Calculate the amount of bleaching powder required to, this is an exercise for you, you do it later at home, okay. You can take a screenshot of this. Overhead tank with 1000 liters needs to be disinfected. Bleaching powder demand was 2 grams in Horrocks test, that is, calculate the amount of bleaching powder required to disinfect the tank. This is asked in the orals by the way. Same thing, household tank contain 9000 liters is to be disinfected. You are provided bleaching powder. 5th cup shows blue color. So how much bleaching powder is required? 5th cup means 10 grams is required for 455. So this is 9000. So approximately 9000 divided by 455 will be around about 20, something like that. Okay. So this you calculate when you get home. Again, another example. A well of 3 meters with 10 meters diameter, 15 meter depth. Horrocks test shows blue color in third cup. Calculate the amount of bleaching powder required to disinfect the well. So these are all examples of this Horrocks test. So this will be probably asked in the exam. They might ask you what is this, don't get confused. They may not go into as many technical details as this, but they will definitely ask you what is Horrocks test, what is it used for, what do you mean by residual chlorine, what happens to the color change, it becomes blue. Okay. So this is the solution for that. The volume of the well is so much, 117.5 cubic meters. So that much liters. As the third cup develops the color, so 3 into 2, that is 6 grams is required to disinfect 455 liters. So for so many liters you need 6 into that much divided by 455, which is roughly 16 grams. Okay, 16 kg, 15.5 kgs. Is this thing clear? Even in a well, you calculate the volume of the well, then the number of, what is the volume of the well is so many cubic meters. The number of 6 grams is required for 455 liters of water. So 6 into volume of the well divided by 455. That much you require for your disinfect, the amount of bleaching powder required. Okay. So this is clear, not a very big problem. Okay. So I think that's about all. So again, another one, this Ria madam brings up all these problems. Might be asked in exam. In the slum, there's a kacha well. Again, same thing, calculate the amount of bleaching powder. You can take a screenshot again. You can calculate it at your leisure. And again, swimming pool. Swimming pool having so much measurement, so much depth, so much breadth. Calculate the amount of bleaching powder, the 4th cup. Okay. It's very simple. 4th cup means 8 grams for 455 liters. Now you calculate the volume of this swimming pool and apply the formula accordingly. Okay. So this is the formula for disinfection of the well. Find the volume of the well in liters. Find the amount of bleaching powder required by Horrocks apparatus. Add the bleaching powder, mix it with water in a bucket. Allow 10 minutes of sedimentation. Transfer the supernatant water, that is the water which lies on top. You transfer it to another bucket. Then deliver chlorine solution to the well. Allow 1 hour contact. 1 hour contact for the well is required. And then you can do an orthotolerant test to measure the free residual chlorine. If free residual chlorine is less than 0.5 milligram, you add more bleaching powder. Okay. Sometimes you go to your friend's house or some other place, you drink water, you suddenly find that smell of chlorine is there, isn't it? Sometimes you might, or you go to some hotel, you might find slight chlorine is, they're probably disinfecting it, but we don't like the chlorine smell. Okay. So if free chlorine is less than 0.5 milligram, add more bleaching powder. So this is the orthotolerant test which we just talked about already. 1 gram of 1.1 ml is water is to be tested. In the OTA, this 0.1 ml is dissolved in 10% HCl. Here it becomes yellow to orange. OTA confirms proper chlorination. It detects both free and combined chlorine. Okay. So this is another method of the chlorination, double pot method. They might ask you, it's then park, I think. So during emergencies and epidemics, you don't have time for a lot of all these things. You have to do it fast. So bleaching powder is put in a pot, and from the hole, it's 2 holes so that it gets disinfected that way. Okay. That's a double pot method. So this is some other tips which are there. 2.5 gram is required, approximately 2.5 grams is needed for disinfecting 100 liters of water. During epidemics, you need more. 5 grams is required. And chlorine required per water is, gallon is 0.84 gram. 1 gallon is equal to 84 grams of chlorine. Okay. The amount of bleaching powder therefore is 84 divided by so many grams. X is percentage of chlorine in bleaching powder. Okay. So these are some of the things regarding bleaching powder and how Horrocks apparatus and things like that. I think nothing more is there. Yeah, again the same question. Boarding school having 500 students also gets water from the tap. Students also drink from the river. So they are suffering from diarrhea. Give you a solution regarding chlorination of the well. When the volume is, well is 2 lakh liters, Horrocks apparatus is also not available. Okay. So you don't have the apparatus, but the students are taking from the well, from the tap and from the river. So what solution will you give regarding chlorination of well? Basically here you have to talk about double pot method. And here again, second one is Horrocks apparatus is not available. You have to disinfect tank water of 45,500 liters. You are provide bleaching powder 21% chlorine. How do you estimate the bleaching powder requirement to disinfect the water tank? Okay, these are slightly tough questions, not at MBBS level, but if you can take a screenshot, you can refer to it later on. Okay. So this is the different water quality standards. You must not have, this is a permissible hardness, permissible alkalinity, nitrites, sulfates, copper, cadmium, all these things. What is the permissible, what is the maximum limit, etc. Okay. So that's all. So those of you who want, you can have it come here and take a look at this. You can touch it, don't break it, touch it. Just see from there. If you want to take a look, you can take it. हाथ दे में ना देख बे ठीक है. You can have a look at this.